Hello, class. We're going to take a look in trigonometry at the graph of a sine function. So we're accustomed to the graph here of the unit circle. And remember, the graph for the unit circle is going to be x squared plus y squared equals 1. So that's the circle. And we discussed how the angles in either degrees or radians are going to intersect the unit circle at certain points, and those points allow us to create the sine and cosine and all the remaining trig functions. So what would be interesting to us now is to see what the graph of an actual trig function is. And in that case, we're interested in our independent variable for x is going to be the angle of measure, theta, and we'll work in radians today. And the output is going to be the sine of that particular measure. So I don't really want to annotate the x-axis with 1, 2, 3, and so on. I'm more interested in some key points. And the key points that we'll be taking a look at are going to be here at 0 degrees. And then we're going to skip and come up here to a point where it's 90 degrees or pi over 2 radians. So this is both 0 degrees and 0 radians. So we're going to work with radians, and we'll call this pi over 2. And then we'll come down and get this other extreme where the angle in radians is pi. Okay, so the distance between my markups here is pi over 2. So that's 1 pi over 2, 2 pi over 2 is pi. And then the third pi over 2 we leave as 3 pi over 2. And then we reach all the way back to the beginning of a period. So this is 2 pi, but it's also 0. Okay, so that's the inputs for our graph of the sine function. Let's get the y, or the output of sine. And we remember that the sine comes from the y coordinate of the intersection at the unit circle. So right here at 0, we have a point 0, 0. Kicks everything off. And then when I go up to pi over 2, the output is 1. So part of the graph, these blue dots are not part of the graph. They're just the x location that we're going to take the sine for. Okay, so we'll draw the graph at the end after we get our points. Now what happens to the sine when I get down to pi radians? The y coordinate or the sine is 0. So we're back down here. So I've got 3 points on the sine graph so far, and then I move on down to the 3 pi over 2 angle, and I see that the y coordinate is -1. So at 3 pi over 2, we're down here at -1. And then finally, when we work our way back up to 2 pi, our y coordinate or the sine is back to 0. And then this is just going to keep repeating itself. If I go up to 2 pi plus another pi over 2, okay, so that would be 5 pi over 2. I'm going to get the same result that I got for pi over 2. Okay, so we really only need to graph one cycle or one period, 0 through 2 pi. Let's go ahead and connect this together, and we see essentially what one period looks like. It's a smooth result. Oops, almost had it. I'll let you see the real thing here in a minute, but if we graph it ourselves, I almost got there. So it's actually going to be at the bottom here. Okay, so let's label these key points, the coordinates. So 0, 0 is one of them, and then for an x of pi over 2, we got a y of 1. Sine of pi over 2 is 1. At pi, we have a 0. at 3 pi over 2, we got a -1. And then back to 2 pi, 0. Okay, let's look at one that's graphed by a grapher. Okay, so if you're not familiar with Desmos, you can get to it at desmos.com/calculator. It's a great little tool. You should maybe check it out if you never have. I'm going to go ahead and create the sine function. So y is equal to the sine, and we're using x as our angle in radians. Okay, so it essentially looks like what we just drew. Well, sort of, but it didn't stop at the one cycle. But we can see here that in terms of the locations, this would be pi over 2 where this top is at. So that would be pi over 2, 1. This would be pi 0. Remember, pi is 3.14 for an estimate to 2 variables. So that's why we see about that distance between 2 and 4 is where pi would be. And then 3 pi over 2 lands back right here. So there's a -1 there. And then 2 pi is bigger than 6, less than 8. Okay, so these are the important key points. And once you've gone there, you can just take that graph and shift it over here and connect it at the ends and just keep doing that because it's just going to recycle. And it'll do the same thing in the negative direction. If you shift it by 2 pi in each direction, it'll just keep doing that. Okay, next one we're going to do is just a quick graph of the cosine. Okay, for the cosine, we're interested in the same points. So let's go ahead and we'll start at 0. But remember, the cosine comes from just mark that up again. Okay, so the cosine comes from the x coordinate. So I know that for 0 radians, we're going to get a 1. So the cosine is actually going to start up here at theta 0, cosine theta 1. And down here we have pi over 2. And at pi over 2, that's where my cosine hits 0. So I know it's going to go through this. And now we have to go look at what happens at pi. So pi, my cosine is -1. So I got to drop down here to -1. And here we are at 3 pi over 2. When we go to 3 pi over 2, it's back to 0. And when we hit 2 pi again, it's at a +1. So that's the end of the period of a full period for the cosine, full 2 pi. So notice this looks a little different. It's still wavy like that, but it's going to start out with this little jobby. Drop down here, trying to make that smooth. And then come up here and start it. So they both essentially do the same thing. They just are shifted away from one another. So let's go look at a full cosine instead of just the one period, once around the circle. All right, so my cosine's in blue, and it does this. It starts at a 1 up here, and this is pi. And then, or I'm sorry, this is pi over 2, 0. This is pi, -1, 3 pi over 2, 0, 2 pi, 1.